Okay. Yeah, I'd like to talk to you today about part of my research that's sort of come up as a side project over the course of various other more um, substantial projects I've been doing under the banner of historically informed philosophy of science, in particular, exploring the boundary between historical approaches and formal approaches to philosophy of science. So that is also the broad perspective that I'll be approaching this topic from. Um, and I'd like to talk to you today about this notion of historical macro unit in particular, um, and argue that this might have a renewed role within historically informed philosophy of science in a way that it hasn't had such a role for the last couple decades. Okay, so yeah, the aim of this talk is twofold, more specifically, to highlight an aspect of the distinctive style of historical philosophy of science that rose to prominence, well, in particular in the 60s and the 70s of the last century, so 1960s, 1970s, also still a little bit in the 80s, depending on how broadly we go. And that distinctive aspect or that distinctive style consists in the use of various kinds of analytical concepts um, around which to structure one's historical account of scientific inquiry that I will refer to here as historical macro units. I will have a bit more to say about this this term later in a minute. But for now, I'd like to just highlight that this is one of the distinctive aspects of this style of historically informed philosophy of science that I would like to say a bit more about. And then second, to argue that the use of such historical macro units to structure one's historical account of science, while largely outmoded or out of vogue in modern approaches to historical philosophy of science and integrated HPS more broadly, may nevertheless find a new purpose when viewed through this particular methodological lens of conceptual engineering. And again, I'll have a bit more to say about this in a few minutes. You can also take here the dual perspective of Carnapian explication, which is a perspective that many people within the conceptual engineering community also take when it comes to pinning down their view on philosophical method. And so that is also a focus that I will be following in this talk today. So it's a simple structure for today's talk. First, I'll say a bit more about this notion of historical macro unit. Then I'll say a bit more about this method of, well, as I was saying just now, Carnapian explication in particular, since that is the lens through which I'll be approaching this broader project of conceptual engineering, although these specific methodological differences will not play a big role today, I should also say in advance. And then lastly, I will say a few things about how I think taking this methodological perspective may allow for a new role for historical macro units in contemporary approaches to historically informed philosophy of science. Okay, so having said that, let me tell you a bit more then about what I mean by historical macro units. So if we adopt a toy narrative on the history of modern philosophy of science, so I say modern here intentionally, we can always include earlier stuff as well, but at least looking at the 20th century, right, and we see this in a lot of introductions to philosophy of science, logical empiricism, who then interacts also with adjacent scholars like Popper, and it might be contentious to place Quine here, but for simplicity's sake, I have done so. And then this is a status quo until right about the 60s when Kuhn comes along, and this then starts off a wide variety of different turns in philosophy of science, as well as various other developments. So, and I've done my best to summarize it in an entertaining and sketchy way here. So We see then in this post-positivist period of the 1960s to roughly the 1990s, and again, we may have debates on the exact dates here, which are not relevant for present purposes, but we see then here in this post-positivist era various developments, one of which being a particular type of historical philosophy of science that, to a lot of people engaging in historically informed philosophy of science today, will also feel quite clear. It will also be quite clear that we saw here, so in this period, in this post-positivist period, starting in the 60s, we see here a distinctive style of historical philosophy of science that in various ways feels quite different from a lot of the stuff people are working on today when they are working on the intersection of philosophy and history of science, be that under the banner of integrated HPS explicitly or more, or in a more general sense. And so then we might ask, well, what is it that makes this particular style of historical philosophy of science so distinctive? And without wishing to generalize too much, because of course, even within this time period, we find a rich variety of different approaches. But if we were to highlight a few characteristic features of historical philosophy of science in this time period, two spring to mind. So one being that to a large extent, a lot of historically informed work during this post-positivist period was still motivated by a desire, and here we see the sort of the remnants of the demarcation debate also rearing its head. But more generally as well, we still see here a broad desire to provide big picture views on the nature of science. So whereas for the positivists, or logical empiricists, I should say, this big picture view consisted in then pinning down a view on scientific method and theory. In this post-positivist era, we then see these big picture views being constructed around distinctive pictures of scientific change. And then the second, and this is the more interesting one for today, the second really interesting and distinctive feature of historical philosophy of science within this time period was that these historical accounts often revolve around the use of various newly minted analytical concepts. The pun intended, the paradigmatic instance of such an newly minted analytical concept was, of course, Kuhn's very notion of paradigm itself. So taking this to be our exemplar, we might refer to this broader category of analytical concepts that arose during the post-positivist era of historical philosophy of science as historical macro units. And I call them macro units to emphasize that these are concepts that are meant to encode various very high level, so macro level features, and I say this here as well, various macro level features of the historical context in which various pieces of scientific knowledge and practices were embedded within a particular era. So I already mentioned Kuhn's paradigms. This will be the familiar example. So we have another familiar example of a historical macro unit in the form of Lacatosian research programs, of course. Slightly less well known, but still up there in terms of prototypical examples of macro units. So Larry Laudan's notion of a research tradition, of a slightly different variety, but still falling under the category, we find Ian Hacking's styles of scientific reasoning. And if we move beyond analytic philosophy of science proper, although even there in that setting, there are more examples to highlight. But even going beyond that, we find various other examples of macro units emerge during this time period. So we can think within history of science proper. We have of course Holton's notion of thema. We have Foucault's notion of episteme. So all of these notions, and that's why I bundle them together here under this heading of historical macro units. We see in the use of such concepts, as diverse as they are, various attempts to codify and bundle together selected aspects of the historical context of scientific knowledge in a way so as to make them analytically tractable. Okay, So, like I said at the outset, the use of concepts of this kind was a distinctive hallmark of historical philosophy of science of this time period, 60s, 70s, 80s. But today, you won't find too many philosophers structuring their historical accounts of science around such concepts. So there's an interesting question here from a historical point of view. If we look at the history of philosophy of science, well, what caused the fall from grace of this particular mode of historical philosophy of science? And here, if you look at the literature, we can identify at least two major reasons underlying the downfall of these concepts. So one major reason is the fact that in a lot of cases, especially in the straight up analytic philosophy of science cases, we find that that the use of such historical macro units is embedded or comes hand in hand with the adherence to a more general theory of scientific change. So for Kuhn, Lakatos, and Lauden, this was, of course, for each one of them, this was also the case, that their use of their distinctive historical macro units was embedded within this higher level theory of scientific change. And as such, general theories of scientific change lost their own appeal within the discipline for various other related reasons, which we will not get into here today. The use of such historical macro units naturally dwindled as well. There's, however, also a second and more conceptually interesting reason underlying the downfall of such concepts. So on conceptual grounds, so even when we divorce historical macro units from their from the theories of scientific change in which they're embedded, we see that a lot of criticisms, even around the time that these concepts were first being introduced, was aimed at their analytical tractability. So speaking of Kuhn's notion of paradigm, in a 1964 review of Structure of Scientific Revolutions, Dudley Shapiro notes that anything that allows science to accomplish anything can be a part of or be somehow involved in a paradigm. And he then concludes that the explanatory value of the notion of paradigm is suspect. Similarly, Nick Jardine, in a review of Larry Lauden's book, Progress and Its Problems, notes that Lauden's notion of research tradition is so vaguely defined as to cover almost any imaginable conglomeration of theories. Okay, so we see now some compelling reasons for why the use of historical macro units petered out as philosophy of science took new turns after the 1980s. So what I would like to say now and to go into now is how this situation, how in light of this situation we are to think of the use of a potentially renewed use of historical macro units within philosophy of science. And here, as announced at the start, I think that, or I would like to argue that, if we adopt the methodological lens of conceptual engineering and application in particular, we do in fact find that in spite of the problems of these past problems with historical macro units, we find that they may nevertheless serve a new function in philosophy of science. So just a few introductory words then on this method of explication, which I said is the lens through which I'll be approaching conceptual engineering. So conceptual engineering broadly, if I just give here my one-line definition, the idea that we construe concepts not as objects in need of elucidation so as to unveil their true essence, but as tools with which to accomplish certain practical goals. There have been many, and there are many ongoing debates on the exact nature of conceptual engineering. I'm bracketing all of those for today. But I will note that in the literature, we do find at least two broad strands of work inspired by conceptual engineering, namely conceptual engineering in the sense of Carnapian explication, and then the other one being conceptual engineering in the sense of ordinary language philosophy. So the first one of these is the one that I will focus on here. So So inspired by a method sketched by Rudolf Carnap in various of his works. The method of explication consists in replacement of a vague concept, the explicandum, by a more precise one, the explicatum. And the explicatum then is appraised in a very pragmatic way. In particular, there's these 4 standard desiderata that then get brought up. Namely, we evaluate explicatum in terms of its practical fruitfulness relative to some predefined goals. And we judge this along with the simplicity of the explicatum, so you don't want your new concept to be vastly more complex. Or rather, I should say, all things being equal, we want to go with the simplest explicatum as opposed to a more complicated one. We can judge exactness and also similarity to the original concept that we were analyzing, so similarity to the explicandum. And there are some classic examples here, of course. So, and people familiar with the literature will know all these examples. So, classic ones discussed by Carnap himself: the replacement of the vague concept of fish by the scientific concept of Pisces. Mathematically, we can replace the number 1 by a more rigorous set theoretic definition of number. And even in modern work on conceptual engineering and also explication, we find people offering various explications of concepts such as gender and race. So this is a very sketchy outline of this methodological perspective, but even on that sketchy view, I think there's already a few upshots we can take away for the use of historical macro units. So first upshot is that we may retroactively construe the proliferation of different historical macro units in the 60s and 70s as attempts to provide explications of the amorphous notion of historical context in which different scientific theories and practices are embedded. And then secondly, and this is particularly interesting here, we may evaluate historical macro units then also in line with the strictures of explication. So evaluate macro units in terms of how well they fulfill certain practical criteria relative to the theory of science in which they appear. And this lens now allows us to not only retrospectively reconceptualize this proliferation of historical macro units, but also to see a new place for them within the practice of philosophy of science. So what might this consist in? Well, it already, adopting this methodological lens already sort of preempts various other more general worries people might raise with the use of historical macro units, also in relation to whether or not the use of such concept is savory from the perspective of employing actors categories. So here I will note as the first and general point that construing of historical macro units as applications of the more vague notion of historical context allows us to bracket thorny issues surrounding realist or anti-realist apprehensions we might have around notions such as paradigms, research programs, or research traditions. And then second, and in a more specific vein, we might also note that by construing of historical macro units as explicata of the explicandum of historical context, this shows us we can already rule out as being useful various various past instances of historical macro units. So I have here in mind, in particular, Kuhn's notion of paradigm in the sense of an explanatory matrix, which Kuhn himself famously defined as being as including almost everything relevant in a scientific theory's historical context. And we might also include under the category of macro that are too broad, Lauden's notion of research tradition. But conversely, we then find that other historical macro units, such as Kuhn's notion of exemplar, paradigm in the sense of exemplar, and even Lakatosh's notion of research program, do fit the bill as notions that can serve as useful applications of historical context. So, yes. So having said this, the upshot then of adopting the method of explication and viewing macro units through that lens is that we can now evaluate a historical macro unit based on how well it serves different practical purposes. And here I argue we can identify two particular practical roles for historical macro units in philosophy of science. So the first of these is the famous one, and the role for which these macro units, as we've seen, had been originally developed. So there's the narrative role. I'm not very attached to these labels, by the way. I just chose them because they seem to be to convey most easily what is going on. So a narrative role. So how well does a historical macro unit allow us to articulate a theory of scientific change? But crucially, we can also identify within various other smaller strands of the literature a distinct relativizing role for historical macro units. And in that role, we ask how well does a historical macro unit allow us to relativize, I should say, the definition of important meta-scientific concepts to the historical context in which the instances of such concepts are embedded. So, yeah, I see I've about 10 minutes, so or 9 minutes actually. So, but that's fine. So, picking up on that observation that we can make a distinction between these different roles for historical macro units, I then advance the claim, which I will illustrate briefly in the next few minutes, but the claim being that by explicitly relativizing definitions of meta-scientific concepts to a certain instance of a historical macro unit, we can minimize historical bias in our philosophical definitions of important meta-scientific concepts. This comes with a caveat, namely that this will often require us to articulate historical macro units with more precision than is traditionally done in this post-positivist body of work. But I want to now, before I wrap this up, I want to then illustrate this claim in the next few minutes by offering an example, and this is one of my favorite examples of how how rational reconstruction or Carnapian explication and historically informed philosophy of science may be brought together. So consider the concept of scientific theory together with the adjacent concept of intertheoretic reduction and the famed notion of incommensurability, as explicated by Wolfgang Steckmuller in the context of the set theoretic formalism that was being developed in the 70s and 80s within the context of the wider program of Munich structuralism. People don't need to be familiar with this program for what comes next, because I will sketch it real quick. So as part of this program, we can give a definition of the meta-scientific concept of theory. So this will then look something like this. So a theory consists of a theory core K together with a class of intended applications I, and then this theory core itself is a set theoretic entity consisting of the various quantities relevant for the theory at hand, defined by means of various set theoretic axioms. So here you have this example for how this would look like for classical particle mechanics. Okay, so this is just real quick to illustrate what this definition might look like on its own. And so crucially, as part of this program, and I will not go over all the details here right now, but what I want to hint at here is that by explicitly treating this notion of paradigm as something that is to be explicated in set theoretic terms, so Steckmuller and the subsequent structuralists give this definition, this historicized definition of scientific theory by appeal to the underlying notion of paradigm that he offer here. So, and it goes a bit in reverse order. So you start off by giving And I see I have a few minutes left, so I'm aware of the time. So yeah, so they start off by then generalizing the flat definition of theory, explicitly including historical components involving the scientific community, SC, as well as the specific historical time period reflected here by H. And then, well, as you can see here, they give this extended definition of the notion of scientific theory, which then includes the intention by the scientific community to apply the theory core K to this class of intended applications over the course of time period H. Building off this historicized definition, they then define or explicate, I should say, the notion of paradigm in a very precise way. So for interest of time, I will not go into these details here, but I can do that in the Q&A if people want. And so I just want to then highlight that this was a highly successful, well, that at least parts of this application may be deemed as highly successful. So in particular, it allowed Steckmuller to attenuate, to tackle the criticism, the famous criticism of Kuhn's theory of scientific change, namely that two incommensurable theories are not amenable to rational comparison. So using the definitions, not quite like this, but similar to this, he showed that we can tease apart a notion of incommensurability in the sense of intertranslatability, which is then distinct from the adjacent notion of reducibility between theories. And so we may secure rational comparison by maintaining the reducibility of one theory to another, while still permitting for incommensurability in the sense of the untranslatability of two theories. Okay, so here I'm just saying that Kuhn himself also endorsed this explication of the notion of paradigm, and that in that sense, then it was not just an exercise in pure formalism, but that it addressed some very pressing concerns that were alive within the wider community of historical philosophers of science. There he is. But there, and here I just hint at some aspects of this explication that leave room for improvement. So I won't get into that right now. Instead, I will just sum up some concluding thoughts. So once upon a time, historical macro units were characteristic of historical approaches to philosophy of science. Two important reasons for the downfall of historical macro units were their connections with general theories of scientific change and their overall conceptual vagueness. The first of these can be avoided by realizing that historical macro units may play a narrative role as well as a more general relativizing role in the analysis of metascientific concepts. So we're not tied to only consider historical macro units in the context of theories of scientific change. And then lastly, the second criticism of the use of macro units can be attenuated by explicitly framing historical macro units as explications of the vague notion of historical context in which scientific theories and practices are embedded. And by doing so, which I have now very quickly hoped to show with this Streckmuller example, and by doing so, we can minimize historical bias in philosophical definitions of important metascientific concepts. And so on that note, I will leave things, and I look forward to hearing your thoughts.
Thank you very much, Bobby. Thank you for your talk. What about if we clap for Bobby? And remember, go to reactions, raise your hand, and then we can move to the Q&A. It would be better if you stop sharing your screen.
Oh, yes. There we go.
Perfect. So questions, people, please raise your hands. Andres?
Hi, Bobby. I hope you're very well. Thank you for your talk. I'm just curious about how would this macro unit, this proposal that you're making, would handle cases where even though you have mathematical structures, they are not unified nor reduced. I am thinking in the case of dark matter, and there you have at least three sound proposals. One is black holes, the other is scalar fields, and the other one is these so-called WIMPs. And so there you need to make a history where you can uh, somehow make comparisons because these concepts have some interplay between them, some epistemic interplay between them. How would this proposal would handle this kind of history?
Right. Thanks for that. So the very brief answer to that would be just that those kinds of differences in structure would be like would be not quite at the level of what you're trying to capture then in this more higher level kind of historical macro unit. Because on the face of it, these would then be three different contemporaneous theories. So then you would just have a difference in theoretical structure that is then underlying, underneath which you still then have this broader historical context, which would be shared and would be encoded within this macro unit. But the slightly longer and interesting response would be that maybe this illustrates an ongoing worry in the definition of these historical macro units, which is namely that how broadly or how finely, or well, yes, how broadly or how narrowly do you define a macro unit? So, and this has been an ongoing point of discussion as well with the use of paradigms versus research programs, for example. Do we only permit that at any given point in history, there can only be one instance of, say, a paradigm relative to a scientific community, or can there be several, right? And so examples like this very nicely illustrate, I think. So I don't have a clear-cut answer to that. So I just want to say this illustrates the need to keep in mind that ongoing conceptual question of, well, how narrowly or how broadly do you define a macro unit, and then can examples like yours do they exist in the same one or in different ones? So yeah.
Thank you, Andres. Thank you, Bobby. Meanwhile, somebody else raises their hand. I want to follow up on Andres' question and express the worry of these three cases. Well, there are three different explanations or three different models, however you want to press the issue forward. They share, the intuition is that they share something. The idea that they are black matter phenomena reconstructed theoretically, right? So when we characterize them as very different theoretical bodies, then it seems that the most intuitive thing that related them at the beginning is lost. And now we have three different conceptual constructions that are focused on the mathematical structure, maybe informed by other commitments, but ideally they that now don't look alike. And that seems problematic, right? Because then it seems that you are caught in part of the historical context in which these things were proposed in science, in order to say, well, you can only focus on them like very isolated, in each case. And ideally, we wouldn't want that when understanding scientific products.
Right. I have a reply which I'm not completely sure whether it picks up on whether it picks up on your point, but maybe what I can say that might preempt this kind of worry is that so I've now given one example, right, of how you can view this notion of paradigm as an explication of a vague explicandum, with a Steckmuller example, and then showing that, oh, if you explicate it in these set theoretic terms, and I appreciate my discussion was quite brief as well, but but then the point was, and oh yeah, if you explicate it in these set theoretic terms, even though that might then distort and then um, take apart or put together various aspects of these different theories that we might want to keep together or might want to keep separate. But by having explicated it in this way, using this set theoretic apparatus, we see that it's a very useful instrument to think about concepts like intertheoretic translatability and the notion of on the notion of what it means for a theory to be reducible to another theory, right? So in that context, and for those and relative to those purposes, this would be a natural way of going about explicating these concepts. Now, if you have other examples, like with the examples that were brought up, right? And that's also part of the point that I want to make, is that if you have a very practical goal, namely I want to have a historical macro unit that accurately reflects these and these and these elements of this big, vague, amorphous notion of historical context in which these theories have been formulated, then you should absolutely also embrace the freedom to look at other, just other historical macro units altogether. So they don't have to be paradigms; they can be research programs as well. And then going further, you don't have to explicate them using set theoretic terms, but you can explicate them using other terms that will do justice to the particular differences between the theories that you're then interested in examining. So I don't know if that helps, but yeah, that's the broad comment that came to mind.
My concern there, and then I move to Kirsten, sorry, would be that suddenly the tools that you are using are going to be more general, because you said, let's move from using set theoretical machinery, and then what are we going to move to category theory, which is going to be too abstract to capture anything that we actually want to capture? Because it seems that what we want to capture is the detail, but also the relation between connecting these macro units relevantly as they occur relevantly connected in the actual history of science, right? And so if we change the formal tool that we are taking for approaching them, maybe what is going to happen is that actually we are going to lose all the connection that we wanted.
Well, so I appreciate this worry. It's also just indicative of a high level worry, I'd say, about how much. So to the extent that we link explication now to the use of formal tools, which I have done in my presentation. Of course, you don't have to necessarily do that, but if we follow that, if we follow with that commitment, then yeah, there is a high level worry about, well, how much relevant historical context can you truly encode using these types of tools, be they set theoretical or otherwise. I'm relatively optimistic personally. Also, if you look at recent work in formal approaches to social epistemology, I'd say. But I mean, I appreciate, and I'm not gesturing very broadly to what's out there. But for now, I'll just say that, yeah, in light of the landscape of possible tools available to us, I am optimistic, but I appreciate that there's a high level worry there.
Thank you very much. And now, Kirsten, please.
Yeah, thanks for your talk. I guess I'm not sure if I have a kind of a fully fledged question here. This is more me expressing, I guess, my state of mind while I'm trying to think about these things. I'm sort of torn, because on the one hand, when I'm thinking about these, sorry, I'm blanking on what you call the meta
macro
units. Sorry, macro units. On the one hand, I kind of end up sort of saying, well, I'm not sure that there's a place in present day philosophy of science really for these kinds of terms. I mean, haven't we all specialized now, and what we really need are kind of local concepts rather than general concepts? So on the one hand, I'm kind of very suspicious of these kinds of general concepts and their use, and I also have this kind of worry that, like, we tend to use these kinds of concepts when we're teaching our undergrads, and then they're such easy concepts for them to grasp that they become really deeply entrenched, and then they make it really difficult for those students to kind of grasp more subtle ideas further down the line. So I've got a bunch of like concerns about the use of macro units in general. But then on the other hand, surely if these historical macro unit concepts are going to be of any use to us, it's because they're so vague. And, you know, if I'm wanting to talk about, I don't know, like, you know, Newtonianism or something, I can go, well, you know, like the paradigm or research program or whatever you want to call it, like however you want to package this, that's fine. Let's use it as kind of vague term. And then I can let it kind of do some work for me or something. So I'm not sure that this move of saying, well, look, you know, we can use these to explicate things, like they can play this important role. I'm not sure that that's the role we want them to be playing. So I don't know. Can you help me to feel more comfortable about this?
That's a good question. I don't know if I can, but so I appreciate that. Also, and so I try to sort of sell you on this idea, right, by saying that no, even if you're not committed to thinking that there's this big pattern in the way science develops, even then there might be a role for them. And then I argued for that. And I know it was a bit sketchy, but I arguing for that by saying that no, like they can play a more general role in the way we then give philosophical definitions of these important concepts, like like the concept of theory and related concepts. Even that move itself already presupposes a kind of, which I didn't really make explicit, but it already presupposes a certain attachment to the value of general philosophy of science and how viable it is in general to give general definitions of these various concepts. So, without wishing to go on a metaphilosophical tangent that will take us too far astray, but yeah, here I just think it does come down to a matter of taste and sensibility, philosophical sensibility, which I would love to also give a more extended defense or motivation of at some point. But I appreciate that if you're also approaching this from the more broader, just informed by a lot of the current like excellent stuff that's going on that takes all these more local approaches. It's totally fair to have this type of skepticism. So if the level of concern is at the level of, well, what point, how viable is general philosophy of science understood in this way, right? Then this will require more elaborate defense on my end. So what I'm saying here already presupposes that you buy in a little bit into the viability of this general project. Thanks.
Well, thank you all for this very interesting couple of talks. And let's thank Bobby, everybody, with reactions and clapping. And let's say thank you. Now we have a break. So what about, we are a little bit ahead. So what about we take 7 minutes and we come back at something 40, depending on wherever you are. So 7 minutes and we come back, okay? For Dubian's talk, my talk, and then we go to bed or we go to eat or whatever your time zone permits.
Could I contest? What about 15 minutes, please?
Okay. If Dubian needs 15 minutes, then we take 15 minutes.
Thank you.
See you in 15, like